So far we've looked at exercises that are just on permutations, exercises that are just on combinations, and even just on basic counting principle as well. The trick becomes knowing which ones to use just given a question. So we're going to just look at a handful of questions. 2007. Mr. and Mrs. Roberts and their 4 children are going to the theatre. They're randomly allocated 6 adjacent seats, single row. Probability that the 4 children are allocated seats next to each other. There's the answer. Now where did I get it all from? Well, 6 factorial, there's 6 people. We're going to arrange all of them, so that's the bottom of the fraction. Top of the fraction then, well, 3 factorial and 4 factorial. Well, 4 factorial, that's the 4 children that want to be together. There's 4 factorial ways of doing that. But now, instead of arranging these 6 people, we're saying, oh, really, we're just arranging 3 objects. 2 adults and the group of 4 children. And we get our answer, 1 in 5. So that's a typical sort of extension 1 question. But extension 2 is so much more fun. Let's show you some of the good ones that did appear in the old course. The bag's got 12 red marbles and 12 yellow marbles. 6 marbles are going to be pulled out without replacement. Calculate the probability that exactly 3 of the selected marbles are red. Answer to 2 decimal places. There's my answer. Where does it come from? Well, bottom of the fraction is the total number of outcomes. We've got 24 marbles, I'm just pulling out 6. Then it's asked us to get 3 red ones. From the 12 red, I'm going to pull out 3, which means then from the 12 yellow, I'm going to pull out 3. So I'm doing it as a combination, because the order that I pull them out, that doesn't matter. I'm just pulling out the marbles, and that ends up being 0.36 when I do that calculation. Well, that part of the question, not too bad. Hence or otherwise, calculate the probability that more than 3 of the marbles are red. More than, there's that key phrase again. So maybe I'll use the complementary idea, maybe I won't. Let's see what it is. More than 3 means 4, 5 or 6. Now I said hence or otherwise. 3 red's not there. Oh well, I'll tell you what, I'm going to go otherwise. If I go otherwise, then I'm just going to work out 4 red, 5 red and 6 red, and there's my answer. It's one of those situations where maybe the or otherwise was quicker. But it is interesting to think, well, how would I have used the other one? Because they did say hence, so there must have been a way of doing it. And here it is. The complementary idea, which, as I say, you probably would think of because it's got more than, there's one of those trigger words. So it's 1 minus, but how I've broken up, I said, well, 3 red or less than 3 red. Now, why do it that way? Because less than 3 red would be the same as more than 3 yellow. Because they're either going to be red or yellow. But the red and the yellow were equally likely. Same number of marbles. So therefore, probability of greater than 3 yellow is the same as probability of greater than 3 red, which I can now move to the other side and look what I've got. 2 times the probability of greater than 3 red is 1 minus the probability of 3 red, which is what we worked out in part A, and I can use the hence part. Substitute it in, and we get the same answer. Was, I guess, the idea they were getting at. Was the or otherwise quicker? Oh, well, it's debatable. Debatable which way you go. All right, this one's even better. We have a chess match. The home team and the away team. The game is played on 4 boards. On each board, the probability of the home team winning is 0.2, probability of a draw is 0.6, and the probability of the home team losing is 0.2. They record the outcomes by listing the games in home team order. So if home team wins on board, well, that should be board 1, shouldn't it? It can't be on board 2. Yeah. Home team wins on board 1, draws on board 2, loses on board 3, draws on board 4. Then we would record as win, draw, loss, draw. So it's the home team's results we're writing down in order. How many different recordings are possible? In other words, how could this end up? Now, this is just a basic counting idea, because on each board, you could get a win, a draw, or a loss. So 3 times 3 times 3 times 3, there are 81 different possibilities we could get here. Calculate the probability of the result, win, draw, loss, draw. What would that be? Well, probability of win we said was 0.2, draw was 0.6, loss was 0.2, draw was 0.6, 0.144. Right, a team will score 1 point for each game won, half a point for a draw, 0 points for a loss. What's the probability that the home team scores more points than the away team? So what's the probability? You'd like to think it was a half, that they both got the same chance, but is it? Well, let's first calculate the probability of them getting equal points. You could have 4 draws. That's going to be 0.6 to the power of 4. Draw, 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 draw. You could get 2 wins and 2 losses. Remember, they've got to get equal points. 2 wins, 2 losses. A win was 0.2, so 0.2 squared. A loss was 0.2, 0.2 squared. But now we're saying, how many ways could we arrange W, W, L and an L? That's like our word problem. Well, 4 factorial over 2 factorial, 2 factorial. There's that many ways of arranging those 2 wins and 2 losses. That gets us 0.0096. Is there another way of equal points? Yes. How about we got 1 win, 1 loss and 2 draws? So that would be 0.2, 0.2, 0.6 squared, but then the number of ways of arranging win, loss, draw, draw, those letters would be 4 factorial and 2 factorial, so 0.1728. I think that pretty much covers all the ways of getting equal points. So probability they get the same number of points is 0.312. So therefore the probability that there are unequal points would be 0.688. But the probabilities of a win was equally likely and the loss was equally likely. We end up with a half of the unequal points would be when the home team has more. And the other half would be when the away team has more. And so we have our answer, 0.344. Pack of 9 cards, numbered 1 to 9. 3 cards are going to be drawn at random and just placed down from left to right. So in a way it creates a 3-digit number, if you like, if you're reading it from left to right. What's the probability that that number exceeds 400? So we've got a 3-digit number. We've got to think, well, what makes a 3-digit number bigger than 400? Well, the key is the first digit. The second 2 digits are irrelevant. It really comes down to that first digit. So it's 6 and 9 because what we're really saying is what's the probability of that first number being bigger than a 4? Or sorry, 4 or more, I suppose, not bigger than a 4, 4 or more. And that would be 6 on 9, so there's a 2 in 3 chance of that happening. What's the probability that the digits are drawn in descending order? Now, it doesn't necessarily mean they have to be consecutive, it just has to be going down in size. So you might have 9, 2, 1, for instance. They would be in descending order. Well, we know the total number of arrangements of 3 digits, whatever the 3 numbers we pull out, would be 3 factorial. We can do it that many ways. So there's 6 ways those 3 digits could be placed. But only one of those arrangements would be in descending order. Therefore, the probability is 1 in 6. So 14F, a bit more fun because now you have to work out, is it a permutation? Is it a combination? Will I try the basic counting principle? How will I approach this problem?